Hi, this is Gerardo Gonzales, and I am going to talk about my sketch for GeoGebra for Mathematics 5344 Technologies course. This program is designed to help with transformations. I set up some check boxes and some sliders over here on the right, some reset values, and a next button. Okay. Uh, Type of function, check 1. So I'll click this box and the parent function shows up. Now the types of transformations, we're going to press the start and stop to see the transformations, and then we're going to press reset to start fresh again. So if I hit start, I can see that this line, the linear function, is changing by the change of this slider. Now if I stop this, I can see that A is 4.75, then I can see how that affects my graph. Now I'm going to hit reset. Actually, I'm going to hit next. It says, describe how changes in the A value affect the graph of the linear parent function. Now, as I go through this first setup, it's going to give me a type of transformation. And if I look right up here, I can see that I put A times f of x. So this A is multiplying the entire function by a value. And we can see that positives make it stretch upward and negatives make it go down, negative. Now I hit next again. A new slider starts and a new transformation. As you can see right up in here, I have f of b times x. Now I'm going to reset this value and I'm going to start b. And it looks very similar to the A. So I'm going to go ahead and stop here, hit next, and it says describe how changes in the B value affect the graph of the linear parent function. Okay, and you can play with these right here. You can slide them and it changes the values in these text box right there. I can also play with these as well. And as always, you can hit reset to start from scratch again. I hit next. Now, in this one, C is always a point of confusion for students. So what I did is I added a point C right here. And once I start it, you can see that it's now tracing a value along the x-axis. I'm going to stop right here. Now this says x minus c, and this is the c value. So as it says x minus 3.5, I've already gone to the right 3.05 units. Okay. Now if I slide this to where this is now negative, well, negative is to the left, and I can clearly see that it's being traced here. But if I were to plug in this negative 2.8 right in here in this formula, it would be x plus 2.8. And that's one of the reasons that I actually put this little trace on function or aspect of this graph so they could see that properly. I'm going to hit stop, hit next. A question appears. How does change in the c value affect the graph of the parent function? And then hopefully they can say that it's translating this left and right or on the horizontal axis. I hit next again and a new variable comes up. But this time, notice that a B popped up. Well, I'm going to go ahead and hit reset. Now I left it there because the trace is still on. Now if I hit start here, this time I have the line going up and down. Now if I weren't paying attention, I could also see that this line appears to be going left and right, and it is, but the transformation that I am particularly interested in is this D value, which is going to go vertically along the y-axis. So let me hit stop, then I can hit next, and it asks me the description right there. Now this next part, let me hit reset. Now when I hit reset, it changes all my sliders back to what I had originally set them for. This trace on is still on, so all I have to do is left click and drag it a little and they'll disappear. Now it says place slider A and slider B so that each is a negative value. Well, I move it to the negative, and I move this one to the negative. And the question that I pose is, place the slider on A and B so that each is a negative value and justify the direction of the slope. Well, when you have two negatives that being multiplied, that does give you a positive value, and hopefully they can see that this is now a positive line. So let me hit reset value, and I'm going to hit next. I also had a pop-up come in this slide. Be sure to uncheck previous boxes so that you can clearly see the transformation of each function. So I'll unselect this one, and now the quadratic function appears. Well, I still want them, a new text box over here. Follow what we did with the linear function. Describe the effects of changing A, B, C, and D compared to the quadratic function. And at this point, the kids will have seen this before, or the user of this program, and they'll get the gist of it. So, they can play with this and see the types of transformations that are occurring. They can hit reset, and you can see the transformations that are occurring along when C is changing, and also when D is changing. Now, the cool thing about this is, which I'm sure we'll have several students kind of do this, and that's fine, because these transformations can occur at the same time, and how it affects the graph, well, that's kind of neat to see, but they'll want to do that as well. So I'm going to come over here, stop all of these, and I'm going to reset the values. Now here it says a blanket statement. Instead of going one by one, I went ahead and changed them all to just describe the effects of changing A, B, C, and D compared to the quadratic parent function. And I want them to verbalize it. I hit next. Well, I also inserted a vertex because the next question says, which transformations affect the value of the vertex? And how do they affect the graph? And then I want them to do a little exploratory, and see, has the vertex changed at all? If so, well, did it? How or how not? So they can play with this and see those changes. Oh, once I started this, the vertex is on a move, and you can see by putting the point out there, you can see clearly that the vertex is moving. I could also hit the D value, and you can see how the vertex is also changing. Also could do a combination of C and D, and it will be moving around in a different type of manner. So let me stop these. One of the big components in math is always comparing and contrasting, and hopefully by asking these types of questions, they can compare these graphs to the parent graph or the parent function, which is still available to them. Hit next, and then describe the transformations as a result of changing the parameters. Now it's the same type of question, but just worded a little bit differently. And once again, I'm going to want the students to come out here and to play with these buttons, start and stop, and be able to verbalize this. And even if they ask me a specific question, oh, I'm sorry, I need to go back over here to quadratics and unselect that and change it to the square root. Now hopefully that'll clear up some things for them. And once again, like I said, they can play with these and ask these questions. And hopefully they'll ask, well, what's a parameter? Well, now you got them asking questions about vocabulary, which is always a good thing. I hit next. Now I'm asking them to actually type in some numbers. They can input this by clicking on the box and putting specific numbers and hitting enter. Now the question I ask is, what does this remind us of? And hopefully some are going to see that this looks like a quadratic just put on its side. So I'm going to unselect this and I'm going to hit next, which now I go to exponential functions. I'll click this one and I'll do some more of the transformations and see how that affects the graph. Same type of question starts it. Describe the effects of changing the parameters. You can reset this, hit next, And then it said, what is the difference in the graphs when A value is negative versus the B value being negative? Well, hopefully they can come over here and see the A value is negative. It looks like it's reflected across the x-axis. Let me hit reset. And then when this one's negative, it looks like it's reflected across the y-axis. It looks like this one is a horizontal stretch, whereas this one is something that's happening vertically. And then they'll continue to manipulate this with the log function, hit next. They have some questions that they need to answer, and they'll cycle through this, hopefully hitting the buttons and checking the start and stops and comparing and contrasting what's available. Hit next. Rationals, you can click this and see how each one of those affect the graph separately. And it says which values affect the vertical transformations. So now I'm talking and seeing if they can, see which one of these actually makes that happen. And the next question, if the slider is set equal to 0, is the function still rational? Working on the vocabulary aspect of this program. Then the absolute value function. They can click it, and they can do all these types of transformations. And hopefully they can see what is happening and hit reset. I'll unselect that one and I'll hit next. Now I've cleared this screen and I've got check boxes. And on these last, I did the absolute value transformations of linear functions and then quadratic and so on and so on. Now the question that I put out here, why do these not look like lines? Well, I want them to be able to answer why that's the case. And it might have to do with something about the absolute value, which it does. I also made sure that I made one of the lines very thick, and I changed the opacity. I think that's the way to say it. And then I also made another line so if they are overlapping, that I could see them correctly. Now I'm going to unclick these, and then I'm going to cycle through the next one. Once again, you can see which directions are these opening and why, and I'm still kind of playing along of asking questions as they go, and hopefully they can answer these. Absolute value of square roots. Are the graphs the same? Why or why not? I want them to be able to verbalize what they're seeing, and if they can make the connection with the absolute value signs of where they're located, whether it's the entire function or just the input value. Same thing here. You can see that they kind of overlap in certain spots. Natural logs, quite different. Does absolute values always give positive values? Hopefully they can answer that. If not, that's something that can be discussed. And then rationals look very similar. And then I have the absolute values. This is my program. I've set up these buttons that they can go forwards or backwards. Next is forward, previous is backwards. And then once they got to the end, I hit start over. Make sure everything was unchecked, and then hit start over, and it starts me fresh from the beginning. That's my program. Gerardo Gonzales, Math 5344, Mathematics Specific Technologies. Thank you.